Welcome back to the Fierce Fish First Tech Challenge CAD modeling tutorial series. Our goal in this series is to provide guidance in using Autodesk Inventor for First Tech Challenge. In today's video, we are going to be looking at assembly constraints. So as we can see here, I've got a couple of different situations here lined up for us. So let's go ahead and get started. So first off, we're going to want to know where the Constrain tab is located. It is right here. When you click on it, this menu will open up. It'll automatically be on the mate constraint with the mate solution. So now that we know where constraint is, let's talk about this situation here. I want this to go right there. We've got to think about how we want to get it there with the Constrain tab. And just as a preface, we're not going to use joint or assemble because those are very restrictive. So we are going to be using Constrain because it allows a lot of freedom in certain movements. So first, let's get the plane, or let's attach the bottom of this to the top of this face here. And the way I can do that, I just use a simple mate with the mate solution. And we're going to click here on that face, and then we're going to click here and hit apply. So the way we're going to do the clicks, as we showed, or as I just showed, is you want to click what you want to constrain to what you want to constrain it to. So as you saw there, I clicked that I wanted to constrain this to this, basically. So now this still moves around quite a bit, but if we go to the front view, it does not move up and down. It only moves side to side. So now next, what we're probably going to want to do is we're going to want to use the flush solution on the mate constraint. And as you'll see, it makes these two sides completely flush. And I'm going to want to do this side to this side, and then apply it. So as we can see here, this only moves along the top here. So let's say I want to attach it right there. Now, as you can probably figure out by now, we're only going to need one flush constraint. But there is something I want to show you here with the flush constraint. A couple of things, actually. Let's flush this. And now we can choose our own offset with this offset indicator here. And let's say I want it 0.5 inches away. Now this is stuck 0.5 inches away from the edge here as we assigned it. So now let's go here on the relationships tab, and you'll see we have all of our constraints here, and let's delete this one here. Just right click and delete. Now this is able to slide again. Now I'm going to show you something called a plus minus constraint. And this can be very useful for if you have, say, like a linear slide component. Let's say I want this to start sliding here and stop sliding when it reaches 0.5 inches. So the way I'm going to do that is do our flush again, this to this, and then we're going to click these two arrows here. You can name it if you want. I don't really name mine. But you check the minimum and the maximum. I want the minimum at 0 because this is where I want to start. Let's do the maximum at 0.5. We hit apply and cancel, and now you'll see this only slides ½ an inch here. So now I think we've pretty much covered all of this mate constraint. And just to get rid of this menu, you can tap those two arrows again. So now let's get into a real life situation about screws. So now here's what I'm going to want to do with this situation. I'm going to want to put this in there and then run the screws through here. So we can use the mate constraint in a different way this time to constrain circular axes center points. So each circle has a center point, and as you can see here, we can use it as an axis. So we're going to want to do that, and let's do to this hole here because that's where we want it. And you'll see those axes here are now lined up. So I can move that from side to side, and it will stay, sorry about the adjustment there, it'll stay on the axes here, and it'll still slide around and do all its things. But now we're going to want to do those two axes there, just like that. So now it still slides around here, and as you can imagine now, we have to do a mate constraint. And then after we do this mate constraint here, this part is completely constrained inside of this grounded U channel. Now there are a couple different ways we can insert screws. So there's a two-step method and a one-step method. So let's start with this two-step method here. We're going to start with the simple mate, and we're going to do the axes of the screw. You can just pretty much tap anywhere on the screw for the center point axes. And let's do it to this hole here. Apply. And you'll get this often save reminders if you haven't saved your part in a while, which I have not. Let's pull that out there. You'll see here now this screw is constrained with this axis. So now what we're going to want to do is use the mate constraint to constrain the back here. I'll just do this right now. Constrain the back here to this face here. I hit that. And now it's going to spin in here. But that's okay because the spinning part is not what we are really caring about here. We're just caring about the spacings here because this is your CAD assembly and what you're going to need to focus on in your CAD. If the screw turns, so what? It won't turn in real life, as you can probably imagine. Now let's talk about inserting this screw with the one-step method. This is called the insert constraint here. If I tap on the insert constraint, we got two solutions, opposed and this is aligned. We're going to want opposed. So the way we're going to do this is we're going to come here into the screw and we're going to tap this line here because it is the outermost line, circle line thing from this face. We're going to want to insert that into that one right there. Click apply and cancel, and you'll see the screw still spins, and that is completely fine. But we have just successfully inserted the screws into the quad block pattern mount inside of this U channel. And that is a real life situation. It's important we're practicing with these real life situations here. You may use a different type of screw there, like a button head, but that's okay. We get the idea. So now let's go and talk about angular constraints. So I have these two parts here. This one's grounded, this one's not. But let's say I want them at a 45-degree angle, or that face, at a 45-degree angle from that face. So there's an angle constraint we can use. And I would suggest using this solution here, directed angle, because then you don't need a reference angle. So we can just click here. We're going to want to constrain that angle to that angle. Right now it's automatically going to be set at 0 degrees. If I want 90, I can do that, but I want 45. So it is going to be at it. This is now a 45-degree angle from that. If you go to the top view, we can see that no matter where I move it, it's always going to be at 45 degrees from that face. Is always going to be 45 degrees from that face. Pretty simple use of the angle constraint there. And again, your relationships, your constraints are in here. Now we have one more major constraint to talk about, and this has to do with the gears. So let's go in here. I've already attached these gears to the Sonic hub, and we're using an 8mm hex shaft here. And I turned this flat plate to be blue so that I can see the difference when I was assembling it. You can very well do that by clicking here, using the adjust tool, and then picking whatever color you so desire. So now we look here, these do not turn automatically together. Inventor does not know that those are necessarily gears to turn together. So we have to constrain them together. So the way we're going to want to do this is first let's start out by aligning the teeth in here. I'd say those are pretty aligned. And now let's go out here and choose our constrain tool. And we're going to want to do a motion constraint And then we're going to do the rotation. There is a rotation translation, but that is if, like, say, a wheel is rotating on a flat surface. So we're going to want to do rotation. And for sprockets, you're going to need to do this for sprockets and belt, pulleys, whatever else is motion like this. So they're going to all use this. Gears are going to use the reverse one because they spin away from each other. And the way we're going to want to do this, you can just tap anywhere on the gear. I like to tap inside the face here, but as long as you tap in the same place in both gears. So I've tapped on both these faces. Now, as you can see, these are the exact same gear, so they don't have a ratio. But if you had a ratio, if you don't have a ratio, you'd leave it as 1. But if you have a ratio, you would put in your ratio there. And then we're going to hit apply and cancel. And now if we kind of zoom in here, you will see these gears now turn with each other. So as you can see in here, Constraint is a very powerful tool to use in Inventor, in the Assembly tab. So that's going to be it for this video. From all of us here at Fierce Fish, we hope you have a great day.